Good day, everyone, and welcome to today's seminar on robots in space. My name is Emmanuel Pinto, and my team and I will be sharing our views and study on this topic. In this seminar, we will be discussing the fascinating topic of robotics in space and their use in space exploration. Now, before we get started, I would like to share our agenda for the seminar. Next slide. As we all know, everything needs an introduction. So an introduction on what exactly is robots in space, moving forward to their evolution, their real-life applications, the challenges they face, and last but not the least, future scope. So now, I members and the topic they're going to share their views on. Next slide. So my teammate, Vishwa Shukla, will cover the topics application of robotics in space. My other teammate, Palak Joseph, will cover the topics challenges and future scope. And I, Emmanuel Pinto, will cover the topic introduction and evolution. All three of us are currently pursuing our BE in Electronics and Computer Science from Father Conceição Rodrigues College of Engineering, Bandra. Next slide. Now let us dive into the topic of robotics in space. Over the past few decades, space exploration has become an increasingly important field of research. One of the most significant advancements in this field is the development of robots that can be used to explore space. Robots have become an essential tool for space exploration, as they can perform tasks that would be difficult or impossible for humans to accomplish. They can also be used to explore dangerous areas such as the surfaces of planets or the depths of space. So, in this presentation, we will discuss the evolution of robots in space, their applications in Chandrayaan and Mangalyaan missions, and how they are changing the future of space exploration. Next slide. Coming forward, the evolution of robots in space. The history of robots in space dates to the 1960s, the Soviet Union's launch of the first space robot. Since then, robots have become an integral part of space exploration. Advances in robotics technology have allowed for more complex missions and greater autonomy. Next slide. So now, in the 1960s, the Lunokhod 1. This robot was designed to study the moon's surface and was remotely controlled from Earth. Since then, the integral part of space exploration has been renewed. In 1970s, the United States launched the Viking missions to Mars, which consisted of 2 orbiters and 2 landers. So the Viking 1 lander touched down on July 28, 1976, and the Viking 2 lander landed on September 3, 1976. So these scientists carry our scientific experiments on the surface of the planet. Next slide. In the 1980s, NASA's Space Shuttle program featured the first robotic arm in the space, which was used for satellite repairs and experiments. The first planetary rover, NASA's Sojourner, was launched to Mars in 1996, making a new era in planetary exploration. So this was controlled from Earth and successfully performed various tasks on the Martian surface, including analyzing the chemical composition of rocks. Next slide. So now in the 2000s, there was a launch of more advanced robotic missions, such as NASA's Mars exploration rovers Spirit and Opportunity, which all of them were equipped with advanced scientific instruments and were able to roam much further than previous rovers. So in 2012, there was NASA's Curiosity rover, the largest and most advanced Mars rover to date. Next slide. Now, recent discoveries include the discovery of water on the moon's surface by India's Chandrayaan 1 mission in 2008. And going forward, the detection of complex organic molecules on Mars by NASA's Curiosity rover in 2008. So by this, I conclude by the conclusion of robotics in space. So now, we'll be looking at the applications of robotics in space. Handing it over to Vishwa.
Everyone, my name is Vishwa Shukla and today I will be presenting on the topic of applications of robotics in space, specifically focusing on India's Chandrayaan and Mangalyaan mission. India has been at the forefront of space exploration for many years and has contributed significantly to the scientific community through its space missions. One such mission is Chandrayaan, which consists of an orbiter, a lunar lander, and a robotic probe. Next slide. Chandrayaan 1, launched in 2008, had an orbiter and a robotic moon impact probe. The MIP was equipped with a mass spectrometer, a video camera, a radar altimeter to study the moon's atmosphere, surface and subsurface. The orbiter had a lunar laser ranging instrument and a high energy X-ray spectrometer to measure the distance between the orbit and the moon's surface and study the X-ray radiation emitted by the moon's surface. Chandrayaan 2, launched in 2019, had an orbiter lander Vikram and a rover named Pragyan. The orbiter had instruments like terrain mapping camera 2, large area soft X-ray spectrometer and a dual frequency synthetic aperture radar. The lander had a seismometer, a thermal probe and a Ligmier probe, while the rover was equipped with a laser-induced breakdown spectroscope LIBS and an alpha particle X-ray spectrometer to study the lunar surface. Next. Chandrayaan 3, launched in 2022, had an orbiter and a lander but no rover. The mission had similar scientific instruments to Chandrayaan 2. You can see a video of Chandrayaan 2 right here. Next, we will be focusing on Mangalyaan. Mangalyaan, India's first Mars mission, consisted of an orbit that carried scientific instruments to study the Martian atmosphere, surface and geology from orbit. Mangalyaan 1 was India's first Mars mission launched in 2013. It carried an orbiter with scientific instruments such as mass color camera and thermal infrared imaging spectrometer to study the planet's surface, atmosphere and geology from orbit. The spacecraft also had a small robotic arm with a spectrometer to analyze the chemical composition of the soil. Next. On the other hand, Mangalyaan 2 is planned to carry a lander and a rover to study the Martian surface in more detail. The rover will have a robotic arm equipped with a drill and a sample analysis system to collect and analyze rock and soil samples. It will carry scientific instruments such as mass organic molecule analyzer and a laser-induced breakdown spectroscope. The Mangalyaan 2 will be launching in 2024. Here's a video of Mangalyaan 1. Next. Let's focus on some of the general other applications of robotics in space. Some of them are robotic exploration, satellite maintenance, cargo transportation, scientific research, assembly and constructions, teleprints, hazardous material handling, mining and resource extraction. So what is the significance of these missions and the use of robots in space exploration? The answer is simple. They allow us to gather data that would otherwise be impossible to obtain. By using robots to study other planets and celestial bodies, we can learn more about their composition, geological history, and potential for colonization or resource exploitation. Additionally, the use of robotics in space exploration eliminates the need for human astronauts to perform dangerous tasks or work in hazardous conditions. Robots can withstand extreme temperature, radiation, and pressure without compromising their effectiveness or safety, making them ideal for space exploration. All in all, India's Chandrayaan and Mangalyaan missions are an excellent example of application of robotics in space exploration. By using robotic probes, landers, rovers, etc., we gather data about robotics technology that has revolutionized space exploration and enabled us to perform tasks that were once impossible. The use of robots in space missions have provided valuable data on Mars and Moon, expanding our understanding of the universe. Now my team member Palak will explain further on future and challenges.
Thank you, Vishwa. Now let us focus on few challenges that are associated with designing and operating robots in space. Firstly, communication delays. Depending on the distance between Earth and the robot, it can take anywhere from a few seconds to several minutes for a signal to travel back and forth. Hence, it causes delays, which can make it challenging to operate a robot in real time, as the operator must wait for a response from the robot before sending further commands. Second, extreme environments. Space is an extremely harsh environment with extreme temperatures, radiation, and a vacuum that can cause significant damage to the materials and electronics used in robots. In the absence of air, materials can become brittle and break more easily, and electronic components can be affected. Third, limited resources. Robots in space must operate with limited resources, including power, water, and fuel. The availability of these resources can be a significant challenge, particularly for missions that require long-term or extended operations. To overcome these challenges, robots in space may involve the use of lightweight and energy-efficient components, as well as advanced sensors and control systems that can optimize power and resource usage. Autonomous operation. Robot must be capable of making decisions on its own based on its programming and sensors. For example, a space probe may be designed to autonomously collect data about its surroundings and transmit that data back to Earth when it is within a range of communication link. Additionally, autonomous operation requires advanced software and control systems that can be difficult to design and test. Therefore, rigorous testing and validation are necessary to ensure the safety and effectiveness of autonomous robots in space. Last but not the least, cost. Given the high cost of space missions, designers must balance the need for functionality with the need to keep cost as low as possible. Space missions typically require significant investment of time and money, and these costs can be even higher for missions that involve sending robots to other planets or exploring deep space. Hence, it is important to explore new technologies and approaches to reduce cost while maintaining the necessary functionality and capabilities. Now let us see future scope of these robots in space. Robots have played a significant role in space exploration, and their use is expected to increase in the future. Few areas that can be looked upon are planetary exploration. Robots can be sent to explore planets, moons, asteroids, where human exploration is difficult or nearly impossible. They can be equipped with a range of scientific instruments to collect data and perform experiments. Maintenance and repair of spacecraft. Robots can be used to maintain and repair spacecraft, extending their lifespan and reducing the need for human intervention. They perform tasks such as changing out failed components, replacing damaged panels, and tightening loose bolts. They can be remotely controlled from Earth or operate autonomously as well. One example of a robot designed for spacecraft maintenance and repair is the NASA Robotic Refueling Mission, RRM. The RRM is a robotic system that was developed to demonstrate the use of robots for satellite servicing and refueling. The use of robots for spacecraft maintenance and repair can help reduce the risk to astronauts and extend the lifespan of a spacecraft. Next is space mining. Robots can be used to extract resources from asteroids or other celestial bodies, which can be used for space exploration or brought back to Earth as well. The very interesting space tourism. Robots can be used to provide services to space tourists such as entertainment or very interesting space tourism. Robots can be used to provide services to space tourists, such as entertainment or assistance with tasks. This includes the experience of weightlessness, viewing the Earth from space, and other unique experiences. Next is search and rescue mission. Robots can be sent to search for and rescue astronauts in distress or to assist in disaster relief efforts on Earth. These robots are designed to operate in the harsh conditions of space and can navigate through zero gravity environments, high radiation levels, and extreme temperatures. They can be developed to locate missing or injured astronauts as well. Once the astronauts are located, robots can provide them with medical assistance. They can also be used to provide them with supplies such as food, water, and oxygen. One example of a search and rescue robot is the NASA Valkyrie robot, which was designed for disaster relief and search and rescue operations. The robot is humanoid in shape and can perform a range of tasks, including opening doors and using the tools. It is also equipped with sensors and cameras that allow it to navigate and operate in complex environments. Using robots has the potential to save lives and provide critical support to astronauts during emergencies. Thank you for joining us for this seminar on robots in space. We hope you find this topic as fascinating as we do.
Thank you.
Thank you.